I don't like कपड़े जो पीछे दिख रहे हैं. Oh, offer of the day. Guys, so आज का हमारा गोल है कि हम लोग एटलीस्ट मिनिमम ओके दैट लुक्स इवन वेस्ट में वापस नहीं उठ कि हम लोग आज मिनिमम 10 आवर्स पढ़ें. ठीक है. आई डोंट नो क्या चला गया. ग्लास लगाना मुझे. Look good, feel great. पढ़ाई शुरू कर रही हूँ. I'm just looking at my goals. Okay, let's read out our goals. Project to start. Make questions for Mel. Okay, no questions for Mel now. Quiz 2. Okay, मैं बाद में करती हूँ. Finish video. 3 LC notes. This is done. फोर एल से एक्स्ट्रा हो गया. गॉडडैम बुक. ओके, आज हम बुक पढ़ेंगे. If is in Java 29 को अंडरस्टैंड करना. I'll start my timer. हाँ, कोई देखने नहीं वाला, बट इट्स फाइन. कल मेरे हुए थे ऑलमोस्ट 4 साढ़े 4 घंटे. नहीं ज़्यादा हुआ ना, क्योंकि मैं सेकंड टाइम टाइमर सेट करना भूल गई थी. वैसे ऑलमोस्ट 1.5 2 घंटे की पढ़ाई. 4 घंटे. कभी शाम भी गया था. एंजॉय. आज का हमने कर दिया है चालू. Let's do 4 lead code. You know what? Let's do the videos. थोड़ा इसको एकदम फास्ट करके देखते हो.
Linked list. And circular linked list is pretty simple. Simply head and tail are connected with each other so that it goes on circle over and over again. Okay, so that's different type. Now let's move on to really implement it. Okay, so first, think about it. In the linked list data structure, right, obviously, I need to write public class linked list. Right, let's just implement singly, okay, linked list. Okay, then, as I told you, each of these boxes, okay, they represent node instances. So when I say node instances, to be able to create a bunch of instances, node instances, in Java, what do we need? Take a moment to think about it. I mean, especially if you took my Java course, 17681, you should be able to answer. What do we need? We need node class. Well, then think about it. We need node class, but I don't want to write node class as a public class because the node class is my implementation detail in my linked list. So what I want to do, I want to use nested class. So let's think about nested class. What is happening is there is a class called outer. In this class, you can also put another class called, I don't know, nested. Okay, so this kind of stuff is possible in Java. This is called nested class. So when it comes to nested class, there are two types. One is static, the other is non-static. Do you know what the major difference between static and non-static? I mean, if you took my 17681 course, you should really know by now. But if you're in doubt, that you're in trouble. Okay, so static and non-static nested class. If you're using static nested class, right, from the static nested classes, you cannot access any non-static members of the outer class. But if you use non-static nested class, you can access anything in the outer class. That is the major difference. The reason is, if you use non-static nested class, this non-static nested class instance has a reference called this to the instance of the outer class. That's why you can do it. So there are two major different this kind of nested classes. Why do we use nested classes? Once again, it's because you don't want to expose your implementation details to other people. You don't need to make these kind of classes to be public as a separate class of this kind of outer class, because that's all you do in your class. Nobody needs. Use those kind of classes. Also, it increase encapsulation. So speaking of encapsulation, let me write this nested class. So class node. So another thing that I want to do before I talk about encapsulation is that, hey, when you use array list or linked list, things like that in Java, okay, when you create an instance of those, you always specify what kind of types in my array list or linked list, which makes. So another thing that I want to do before I talk about encapsulation is that, hey, when you use array list or linked list, things like that in Java, okay, when you create an instance of those, you always.
Wait, did someone comment? Okay. Danny Parazu. I don't know who you are. Okay, I really hope it's not my Danny. Like, not my Danny, but the one I know. That would be hell embarrassing. See, this channel is not supposed to be found by someone. I just do it for my sake. I will like, oh, this is like some. Wait, this person has posted some. Like, this person has a playlist about Bitcoin and stuff. I don't think my US fella Danny would do that. He's too stuck up to do anything else. I don't like this. Anyway, let's get back to the video. I can delete this.
Specify what kind of types in my array list or linked list, which means the code for this kind of classes should be generic. It should be able to take any kind of types when someone is instantiating and then giving some sort of type parameters. So what I'm trying to say is that we can also use generic programming because so that people can use this kind of linked lists when they want to use any kind of types. Okay. So for that, I'm going to say any type. Okay. Right. That means this class linked list should be also any type. Okay. So here in this class, let's think about it. If you write this way, this is default. That's not good. Okay. First thing you need to do, if you're not sure, private. Okay. Let me illustrate this. If you took my Java course 7681, you know what I'm about to talk about. But let's do it one more time because I want to make sure you remember this. Okay. Let's say if you're watching, okay, let's do this. Let's introduce to each other, or me and yourself. Okay. Let's shake our hands. Even if obviously these days we cannot shake hands, but let's shake hands. So if I shake hands, the first time we met for the first time, we shake our hands. And then we introduce each other, okay? Let's say, I'm Terry, and then you say your name. And after the introduction, the first thing I'm gonna say to you, you can touch me anywhere on my body. Would you ever say that? Probably not, right? My hands are okay, my shoulder is okay, but like the other part, no, okay? You need to declare your vulnerable parts to be private, right? Private. So if you're not sure what to do with that, make sure you write private because you need to make sure you encapsulate, you hide your implementation details. Private, right? And then here, in the singly linked example right there, right here, right? What do I say? We have data, we have next reference. So in this class, we need to have, once again, even though I don't need to do it, I'm going to write it again, private, any type data, right? And then we need to have a reference, private, node, any type, next. Okay, things like that. And then node, constructor, any type, d, node, any type, next, data. All right, so that's the structure. Okay, we have two variables, data, the next reference, the constructor, taking any type and node, and then set those. Okay, notice this. Look at this. In this nested class right here, okay, do I have any code that tries to access any kind of non-static members of the outer class? Obviously, we don't even have any kind of non-static members over there. Okay, let's write that. Private node, any type, right? We're starting with the head, right? Head, right? And then public linked list. Right, even though I don't have to write it, I'm going to make it very clear by saying head is initially null. Okay, so look at this. I have one instance variable and then one constructor. But in my nested class, do I have anything to do with these kind of variable or constructor, whatever? Nothing. Okay, in that situation, as I told you, you got to make sure this is static. Okay, because I don't need to access. Okay, the question you need to ask when you choose static or not, do I need to access any non-static members of the outer class? If the answer is no, meaning you don't have to access any non-static members of the outer class, make sure your nested class is static. Okay, right, so that's the one. Okay, so let's now write bunch of operations. The first thing I'm going to do, public void add first. Okay, so I mean, right, let's pause. A lot of times when you try to find a bunch of example code files on the web about linked lists, a lot of people use actually Node or entry, whatever class that they name it. But then when it comes to this kind of operation, if you find any code that is getting the type of the parameter is Node, something is wrong. Because Node is your implementation details. All you know is whatever type they're about to pass, they can pass it. So this should be any type, not Node. This is not Node. This got to be any type. All right. So if you add first, what do we do? What's performing? So simply, if I look at this picture, what I'm trying to do here, let's say I'm adding H new node. First, what I need to do, I need to create an instance of H, and then make sure I'm connecting this one to this current head, and then later I replace, I make a change for head to point to this newly created node H. So this is add first. So how do I achieve that? Simply, I need to do new node any type, okay, by passing this item, right, the constructor of their item, and then what's the next of this newly created node? The current head, right? And then after you're done, make sure the head is now updated.
Okay, I really hope Danny did not see it. मुझे नींद आती है ना बताओ.
To point to the new node that you just created, like this line. I mean, this is possible because this assignment operator is right associative, meaning this is going to perform first before you assign head to point to this new node. Right associative, meaning it's going from right to the left. That's why this is working. Add first, right? And then the next operation, let's perform another operation. Add last. Okay, so let's change it. Add last. Okay, so if I add last, let's check some of the corner cases. I mean, let me emphasize, the code I'm writing here, they're not perfect. They're not complete. There are a lot of things that you need to take care of, like validation, things like that. So I'm not going to write those, but that doesn't mean that you shouldn't take care of it. You should take care of those kind of stuff. All right, but at least we can take care of one edge case here. So if head is equal to null, right? What does it mean? Meaning this is empty linked list. If it is empty linked list, add last is simply the same as what? Add first. Meaning here I can simply call add first by passing the item, right? And then simply return. Right? Do you notice this? You don't have to write the same code over and over again. You can reuse by calling. to point to a new node that you just created, like this line. Picture. Okay, when I try to add last, what I need to do, I need to create H right here, right? And then this. Right? Do you notice this? You don't have to write the same code over and over again. You can reuse by calling this existing method, right? And then after that, so if I want to add last, let's go back to the picture, right? Let's go back to the original head. Okay, here, this is head. So if go back to this picture. Okay, when I try to add last, what I need to do, I need to create H right here, right? And then this is obviously pointing to null. And then this last node, instead of pointing to null, should be pointing to this, right? So that means the first thing we need. If I go back to this picture, okay, when I try to add last, what I need to do, I need to create H right here, right? And then this is obviously pointing to null. And then this last node, instead of pointing to null, should be pointing to this, right? So that means the first thing we need to do, we need to make sure we go from the head, follow the reference over and over again to get to this point, which makes it to think about, right? This is called the sequential access data structure. I mean, linked list, unlike array list or array, this is not random access. The only thing you know is where the head is. You need to follow this kind of chains or links to get to a certain point in the middle or to the last. Right? Let me illustrate this way. What is this? You know what this is called? This is tape measure. So tape measure, think about it. When you try to measure something, what you need to do, you need to pull this one from the head, and then you measure something like this. And once you're done, boom, gone. And next time, when you try to measure, what do? You pull from the head, and then measure, right? And then none, and then it's gone. Every single time you need to go through the head, okay? This is what is called the sequential access. So next time.
किसमें?
एक दो लाऊंगा मैं, भर भर के फ्रूट नहीं लाऊंगी.
Okay. So
एक मैंगो रखा है तो मैंगो नहीं लाऊंगा.
से मैंगो के खाने में डिफिकल्ट होता है.
तो मैं क्या लाऊंगा? तो
बनानास ले आना, एप्पल ले आना.
एक दो ही लाऊंगी अभी, फिर जब लगेगा फिर लाएंगे. जैसे मैं फ्रूट बास्केट नहीं बना सकता. ऑरेंज तो अभी इस टाइम आते नहीं, मौसम भी आते हैं स्वीट लाए.
डिफिकल्ट टू ईट. काटना पड़ता है ना.
अभी दो ही ले आते हैं, फिर जब कभी ऐसा लगे दूसरे कुछ ले आएंगे.
अगर लीची मिल गई जस्ट इन केस.
लीची वो ठेले वाले लेके जाते हैं, अगर मिला तो ठीक है, मैं आती हूँ आधे घंटे में. 10 बजे वैसे तो अभी वो आएगी और वो रेडी रखा है.
हाँ.
वो भी ले आऊँ, कलर भी लाना है.
Sorry.
Measure. Think about sequential access data structure. So now, at last, to be able to get to this K, we got to go from the head and then find the last one and then edit. So let's write that code. I mean, obviously, I cannot move the head reference. Head reference should be staying there, but I need to use another reference. Let's call it like temp, right? And then starting from the head, go forward, following the next reference over and over again until we get to this point, right? So let's do this. So node, anytime, temp, starting from the head, right? And then we got the while, okay, here, right? So we got to actually, right, let me check later. But the simple thing is we simply temp need to be now temp dot next over and over again until you get to a certain point. So what is the stopping point right here? When do we stop? Can I do temp not equals null? Is this a good stopping point? So if I write this way, you know what's going to happen? If temp is starting, if temp is pointing to null, that means we already passed this last element. So we cannot do temp not equal to null because we just passed this K. So to be able to stay at the last node, what we need to do, we need to make sure we need to do temp the next is not equal to null, right? Then we know temp is now finally pointing this K, right? Not the null after the K, okay? So temp, while temp not equal, next not equal to null, you go on and on and on. And then eventually, what do you need to do? You need to create a new node, any type, okay, passing item, right? So this is new last node. So the next should be simply null, right? And then this one should be pointed by temp dot next. Okay, that's simply add last. Okay, right now let's do insert after. Okay, this time what we're gonna do, we're we're going to find certain key element and then insert after that. Okay, so we're using a key to find a certain element and then insert something after the key. So for example, right here, what I'm trying to do here, I'm gonna, okay, so let me change this to the original state. Right, so what I'm trying to do here, I'm trying to add H, where? After I. Because the key, if I pass the correct value, key is I. So let's say key is I, the element that I'm trying to add. H, right? So simply, I need to update this one, and then this newly created node should be pointing the next node of the I, right? So let's write this. Okay, so node, any type, temp, starting with head. Okay, we're gonna go on by updating temp to be temp.next. Okay, so what's the thing we need to perform while we're trying to go through over and over again? The first thing we need to do, obviously, we need to compare the key with the element. So temp, can I do temp.equals key? If that is not true, just keep going. Can I write something like that? Temp.equals key, something like that? No, what is temp? Because temp is node. And then what is key? Key is any type. So what we need to do, instead of doing temp.equals, we need to use temp.data.equals. Okay? If that is not the case, keep going. But is this good enough? The next thing you need to do, hey, when you're trying to find a certain node using the key, you got to examine every single node. Then you need to go all the way, right? What it means, if the temp is not equal to null, and that is not the same case with the equal, then you just keep going. But this time, you got to do temp not equals null. Because if you stop temp.next not equals null, then you don't compare. You don't examine this last node. You now, this time, you go all the way to the null. Okay? Another thing, a lot of times, students like, let me swap this order, right? Let's check this null after I check the equality. No, that's not the case. The first thing you need to do, the order matters because this is evaluated in short-circuited fashion, and to make sure this is first checked.
I had like a really bad itch in my ear, so I had to go. I mean, initially I was just eating a banana, then my hands got dirty, so I was like, let me wash it. Then I got like this really, really bad itch. I'm like, okay, anyway, let's get back to the video.
And then you check this one, because if you don't check this first, if the template is null, what's going to happen? It's going to throw null pointer exception. So be careful with that. All right, so if after the checking, if template is not equal to null, which means you found it. I mean, if it is equal to null, that means you didn't find it. So if you found it, then the new node any type item. Okay. The next node of this newly created node is what? Temp dot next. Right? Because if I'm looking for I, okay, I order matters because this is evaluated in short-circuited fashion. You to make sure this is first checked, and then you check this one. Because if you don't check this first, if the temp is null, what's going to happen? It's going to throw null pointer exception. So be careful with that. All right, so if after the checking, if temp is not equal to null, which means you found it. I mean, if it is equal to null, that means you didn't find it. So if you found it, then the new node with that. Right, so if after the checking, if temp is not equal to null, which means you found it. I mean, if it is equal to null, that means you didn't find it. So if you found it, then the new node type item. Okay, what's the next node of this newly created node? Is what? Temp dot next. Right? Because if I'm looking for I, okay, okay, is going to be, right? And then obviously, then we need to check. We need to link temp dot next. Now it's pointing to this newly created node. That's insert after. Right? Now let's talk about insert before. Right? Let's tweak a little bit. This time, it's pretty much the same thing that we want to achieve, but this time, I want to insert before whatever key I'm looking for. Okay, so insert before. Okay, so let's think about this situation right here. This time, okay, I'm still trying to add h right here, but the key that I'm passing when I call the method is end. Okay, by the time I found whatever it is pointing this end, I'm trying to insert before end. Okay, so let's talk about it. This is a little bit more involved, so pay attention. Well, let's check to some corner cases. Let's talk about insert before, right? Let's tweak a little bit. This time, it's pretty much the same thing that we want to achieve, but this time, I want to insert before whatever key I'm looking for. Okay, so insert before. Okay, so let's think about this situation right here. This time, okay, I'm still trying to add h right here, but the key that I'm passing when I call the method is end. Okay, by the time I found whatever it is pointing this end. I'm trying to insert before n. Okay, so let's talk about it. This is a little bit more involved, so pay attention. Well, let's check to some corner cases. If head is equal to null, then what? It's empty. I mean, if it is empty, do we need to do anything for insert before? Obviously not, so we simply return. Okay, and then if head dot data dot equals key, right? Then what it means, the key that I'm looking for is at the head. Right? If I try to insert before the head, what am I doing? It's basically same as add first. Okay, so you call add first by passing item and then return. Okay, so those are the two corner cases you can take care of. Now the real case, let's think about it. Let's go back to the picture right here. So if I have h to be inserted in the middle like this, so if I'm looking for n as the key, okay, so by the time I found n, whatever reference, it's going to be pointing n. Okay, sure. So after I create h, I can actually make a connection between h and n. That's good enough. But then the question is, how do I make a connection between I and H? Because we still need to make a connection between I and H. We just passed I. So once you pass I, you have no idea where I is. So what do we need to do? Well, there are many different ways to implement it, but one easiest way is, this is one way I can think of, I have another reference to point I, right? So-called some sort of following reference, okay? So that's what we're gonna do. Let's write two references. Node, any type, previous, starting with null, right? And then the second reference, node, any type, current, starting with head, okay? And then here, we do exactly the same thing, while, at this time, if current is not equal to null, and so current dot data dot equals key is not the case, meaning we're still looking for a value, then let me grab some more chalks. Then we got to update. But this time, we have two references. Before you update current, so I mean, if you think about it, this current is pretty much the same as the temporary variable that we use in insert after. So current is going to be simply current.next. Okay, but before I update, I need to make sure I update previous to be current. Okay, so that previous actually follows current. Every single time the current goes, previous follows right behind it. Like, I mean, I have a younger brother. When I was young, when I tried to play with my brother and with my friends at a playground, my father used to tell me that, hey, you can go out and play together, but make sure you watch your brother. And then they told my brother, make sure you follow your older brother, right? I mean, pretty much, you can imagine that this is actually memory playground, and these are brothers and sisters. And then the younger sister or younger brother, those older brother or older sister, things like that. So anyway, that's previous and current. And then obviously, if current is not equal to null, then what? We found it. Once you found it, then we got to make a connection. Node of any type, okay? And then item, okay? Now, what's the next for the newly created one? Obviously, that's got to be current, right? Because, hey, if you look at the picture right here, by the time the while loop is done, current is going to be pointing n, and then previous is going to be pointing I, okay? So the current should be the next node of the h, but then we still need to make a connection between these two, I and h. So how do we do that? Easy, because I have previous reference, I can simply the previous dot next is now pointing the new node. That's what I need to do, okay? So that's insert before. Moving on, let's do remove. remove. All right, so this time, we're not inserting anything, so remove. We pass some sort of key to delete. Okay? All right, so that's remove. So let's check the corner case, pretty much same thing. If head is equal to no. Okay, obviously this empty linked list, do we need to do anything for the remove? No, like nothing, return. Okay, and then the next corner case is if head dot data dot equals key. Right, what it means, the key that I'm trying to remove is at the head, right? So what do we do? It's so simple. Simply head is now head dot next and return. You're done. I mean, for example, like in this picture, the thing that I'm trying to remove is what? L, right? What do I do? It's simply head to the point to I. We're done, okay? All right, now, let's the real one. This time, let's think about it. If I'm trying to remove something using the key, I mean, let's go back to the original picture. Head right here, right? Let's say this is the original one here, right? Something like that. Let's say I need to remove n. Yeah, I got to remove n. So to be able to remove n, obviously, first thing we need to do, we got to find where n is. But then after we found where n is, what's the thing I need to perform? I need to make a connection between I and k, right? Meaning, we simply snip this one out of the connection, right? That means not only I need to know where this is, but also I need to know where this is. I mean, sounds familiar? This is pretty much the same as insert before. So we need two references. Node, any type, previous, null, node, any type, current, head, right? Same thing, while current is not equal to null, go all the way, and also current dot data dot equals t is not true, then we simply keep going by updating first previous to be current, and then current to be current dot next. Okay, so that's it for the while loop. And then if current is not equal to null, right? Then we know we found the key. Then what do we need to do? Same. Okay, so this time, after we're done with the while loop, look at this. This is pointed by previous, right? This is pointed by current. Do you see that? Okay. Now the only thing we need to do, we need to make sure we connect this and that, I and k. Snip this out of the connection. So the way we write is pretty simple. Previous next should be current dot next. Okay, that's remove. Okay, so that's linked list operations. Now let's talk about something else. n is. But then after we found where n is, what's the thing I need to perform? I need to make a connection.
गाइस मेरी मॉम जस्ट अभी लाइक फ्रूट्स लेने गई थी और मेरे लिए वड़ा पाव लेकर आई. अभी नहीं खा रही, थोड़ी देर से खाऊंगी. लेट्स फिनिश दिस थिंग फर्स्ट. और ओके मैं जब अपना कान का थोड़ा इरिटेट होकर गई थी तो आई फॉरगॉट टू सेट ऑफ माई टाइमर. तो मैंने 10 मिनट पहले विच वॉज 10:16 उस पर अपना ऑफ कर दिया था. एंड नाउ इट्स 26. तो सिमिलर. Should I open my air? Clutcher हटा दिया. I'm really curious who this Danny Perazzo is.
After we're done with the while, look at this. This is pointed by previous, right? This is pointed by current. Do you see that? Okay. Now, the only thing we need to do, we need to make sure we connect this and that, I and K. Snip this out of the connection. So the way we write, it's pretty simple. Previous next should be current dot next. Okay, that's remove. Okay, so that's linked list operations. Now, let's talk about something else. This time, whenever you use, like array list or linked list, you sometimes try to iterate over a bunch of elements. For example, let me write this kind of code. You do something like this. List, integer, numbers, okay, new, linked list, integer, something like that. So you create an instance of linked list, and then do what? Numbers. You add a bunch of elements, add, right? Numbers, add, right, 2, go on, like add 3 or 4 and 5, bunch of stuff. So after you add a bunch of elements, right? And then you get to write something like this. Iterator of integer, iterator. What do you call that? To have a variable called itr, right here, from the numbers instance, you call iterator method. Have you tried that? I'm pretty sure you have. Okay. Also, after that, you do check while iterator has next, right? And then, I don't know, you do something like system.out.println of iterator.next. We call this kind of method. Okay, things like that. And have you ever written this kind of code? I'm pretty sure you have. In fact, even if you didn't write this way, if you use like for loop, okay, where you have for loop, things like that, you know what's happening behind the scenes? It does use this kind of operations, iterator. So what's iterator? So we got to talk about iterator. Iterator is a way of accessing a bunch of private elements, like this kind of code here. Linked list, a bunch of private nodes. How do people access those? Without having some sort of operation, they cannot. So that's why we have this kind of iterator. Now, we need to think about that kind of operation that we need to have in our linked list implementation. To be able to implement this kind of operation, you know what we need to do? We need to implement 2 interfaces. 2. What is this? One of those. First, iterable. and iterator. Those are the two interfaces that we have to properly implement to support this kind of operation. So let's think about it. There are two interfaces. So for the data structure class itself, let me bring this down. Right? Let's think about it. This linked list class. Okay. I mean, how do you implement interfaces? How would you write the code? Typically, you write implement and the name of the interface, right? Okay. So what do we need to do? So it's a simple plain English. This linked list should be iterable. So what it means, I need to implement iterable. Now, right? Let's think about it. This linked list class. Okay. I mean, how do you implement interfaces? How would you write the code? Typically, you write implement and the name of the interface, right? Okay. So what do we need to do? So it's a simple plain English. This linked list should be iterable. So what it means, I need to implement iterable of any type, right? So this linked list class itself implements iterable because this class has to be iterable. If the class is not iterable, you cannot iterate through, right? That's simply not. So that's why you implement iterable. So as soon as you write this implement iterable, you know what's going to happen? Especially if you use IDE like Eclipse, right? It's going to complain, meaning it's not going to compile, right? And it's going to tell you to do something about it. You know what's the first thing that it's going to tell you? Add unimplement methods, right? So if you click on it in this class, let me delete this. In this class, right here, right below, it's going to write something like this: add override, right? I mean, let me emphasize. If you ever implement any kind of method in interfaces, you must start with writing override annotation like this. Okay? So at override, public iterator of any type, and the method name is obviously iterator. All right? And then by default, simply it's going to say return null. This is it. I mean, like, think about it. This right here, iterator method, with the instance of whatever data structure that you